and good day, Algebra. We are going to start off the week with negative powers. It's the fourth of 5 rules that we're going to talk about with exponent expressions. We started with multiplying by the same base in CO10. We went to dividing by the same base in CO11. CO12 was up with a 0 power, and now we're getting to negative powers. See, negative powers. And we're basically going to look at what happens here. Using patterns, because like when exponents were first discovered and taught in math classes around the world, there's that kid in the back of the room that always, what about when the exponent's 0, right? Then they had to figure out what happened with the 0 power, and we learned about that in CO12. And the next logical step, what if the exponent's negative? Math is not invented, right? Math is discovered. If for those that are familiar with the Pythagorean theorem wasn't like invented by Pythagoras. It was discovered. The relationship of the sides of a right triangle have always existed. 2 objects have always made 2. We just kind of discovered that, right? So what they did was they looked at, well, let's see what happens when we've got positive powers and kind of work our way down to negatives and look for a pattern. Okay, so I recommend that you make this or a similar chart. I'm going to try and space out my jottings here so it all fits. You might want to do the same. But we're going to start with 2 cubed. Okay, we're going to go like this, maybe like this. That looks like a good chart. We'll put something like, there we go. I don't know. Okay, what does 2 cubed equal? Max? 8, yes. Okay, 2 times 2 times 2. All right, cool. So now let's keep the same base, but let's decrease our power by 1. Okay? Because if we continue to do this, eventually we're going to get down to negative powers, right? Let's just see what happens here. What's the value of 2 squared, Alex? 4. All right. Let's do it again. What's the value of 2 to the first? Again, decrease that power by 1. Kylie? 2. Here's where CO12 comes into play here. Decrease our power again. 2 to the 0 power. What do we get? Ellen? Any base of 0 power is 1, right? So we're going to stop here, and let's kind of take a look at what's happening. As we decrease our exponent by 1, what's happening to the value? From 2 cubed to 2 squared to 2 to the first to the 0. Catherine? Sorry? It's getting smaller. Okay. Jack?
It divides by 2.
How it's getting smaller is that it's being divided by 2 each time, right? From 8 to 4 to 2 to 1. And it makes sense why this is happening, because if we look back at expanded form, 2 cubed is 2 times 2 times 2, right? That's how we get to the 8. 2 squared is 1 less 2. So it's going to be half the value of 2 cubed because we're not doubling a third time, right? 2 to the first is just a 2. We're not doubling that again, which is why 2 is half of 4, okay? Then here's where the patterns kind of kick in, and 2 to the 0 power, is really not an expanded form for that. It's just 1. But what's going to happen here for 2 to the negative first? I've kept my pattern on the left column here the same. I've decreased my exponent by 1 again, right? From 3 to 2 to 1 to 0, now to negative 1. Following the pattern, what's the value of that going to be, Christopher? 1 half. 1 half. Okay? 1 half. Following this pattern, what is 2 to the negative second power going to be? Following this pattern. Alex? What did you say? 1/4. 1/4. Following this pattern again, going down to 2 to the negative third, what's this going to be, Kylie? 1/8. Okay. So let's stop here and take a look at what we have going on here. Is anybody surprised that we don't have any negative values over here? It kind of seems that way because, twice it happened when we were going through these. We started saying negative and then we corrected ourselves. So when I said that we're starting the week off with some negativity, I lied. It's all positive. It's all good. Okay, that's all good. The first thing to note here is that a negative exponent does not make the base negative. Noah, what does a negative exponent not do? Make the base negative. Let's focus up here. A negative exponent does not make the base negative. Okay? So then, what does a negative exponent do? Does anyone see any connections here between what we have on the right side, that column there? Jack?
For negative, you just put a 1, then a line.
So we turn it into a fraction, what that called, right? Okay. What else do you see? What are the patterns? Kylie?
You still do the exponent or the power like it's not negative, and then you just put the answer with the 1.
Yeah, kind of what Kylie's saying here, I think I'm on the same wavelength, is that notice how for 2 cubed, we end up with an 8 there. 2 to the negative third is 1 over 8, right? There's that connection with the 8s there. 2 squares of 4, 2 to the negative second, 1 over 4. 2 to the first is 2, 2 to the negative first, 1 over 2. Okay? What's happening here? In expanded form, Kylie's exactly right. What we did was we took that 2 and we moved it to the denominator of the fraction. 2 to the negative second power, where does that 4 come from? It comes from 1 over 2 times 2, which is the same expanded form we had for 2 squared, right? 2 times 2. Only now, since it's negative, it's in the denominator of that fraction. 2 to the negative third, 1 over 8. Where does that 8 come from? Comes from 1 over 2 times 2 times 2. So there's a connection here between a positive power and a negative exponent. Basically, it's opposite. The expanded form for 2 cubed is 2 times 2 times 2. The expanded form for 2 to the negative third is 1 over 2 times 2 times 2. The value of 2 cubed is 8. The value to the negative third is 1 over 8. Okay? So, as a sidebar, what's the value of 3 to the negative second power? Change the base a little bit. We can still follow kind of the same rules here. Crinkle?
1 over 9.
Very good. 1 over 3 to the positive second power, or 1 over 9. Again, a negative exponent does not make a base negative. Does not make a base negative. How about what is 5 to the negative third power? Those of you that know your exponents well. Wyatt? Good. 1 over 5 to the positive third, or 1 over 125 when you multiply that out. Okay. How about, I'm going to try and trick you folks here. How about 1 over 7 to the negative second power? Aha. What's this one going to be? Now our negative exponent's in the denominator of this fraction to start with. Andrew? Not going to be 1 over 49. Alex? Nope. A negative exponent does not make a base negative. I should have mentioned that earlier. Noah? It's just going to be 49. 1 over 7 to the negative second power is equal to 7 to the positive second in our numerator, which equals 49. So, can anybody tell me the rule for a negative exponent, right? Because we have this little section here where we always fill out what do we do with the coefficients, what do we do with the exponents, what do we do with the bases. What's the rule for when you have a negative power? Alan, what do you think? Okay, that's kind of explaining what's going on here, right? But then when we don't have a pattern to work off of, when it's just an isolated thing, 3 to the negative second power, what do we do to get from 1 over 3 squared or 1 over 9? From 5 to the negative third, this kind of looks like a negative sign here. I'll fix that. Yeah. 5 to the negative third is the same as 1 over 5 to the positive third, or 1 over 125. Then I threw you a curveball. 1 over 7 to the negative second is actually equal to 7 squared. You can put this over 1 if you want to. Might help visualize it more easily, which equals 49. So what's going on here, Kylie? Okay. Crinkle? What are you going to say?
I was gonna say, like, you basically just do the exponent, and if it already doesn't have a numerator, you add a 1.
Okay.
And then if it does have a numerator, you just do the exponent.
Okay. What we're doing right now is essentially what mathematicians needed to do when that kid in the back of the classroom asked about negative powers, right? They all got together, met at like Perkins or something like that, and they said, what do we do? What do we do? And they looked at this, and what they kind of summarize it, what all that you're saying is correct, but kind of as a summary, what happens is the exponents moves to the other part of the fraction. And becomes positive. Okay? The exponent moves to the other part of the fraction and then becomes positive. Moves to the other part of the fraction and becomes positive. 3 to the negative second became 1 over 3 to the positive second, right? It moved from the numerator to the denominator. The exponent became positive. 5 to the negative third became 1 over 5 to the positive third. Moved the other part of the fraction, became positive. When we had a negative exponent in the denominator, it moved to the numerator and became positive. That's essentially what's going on here. How about the base? What happened to the base in all of this? Here we had a bunch of bases of 2's. Here we had a base of 3, a base of 5, a base of 7. What happened to the base, Christopher? Yep. And anything else? Stays the same. Okay, we're back to that, right? So the base follows the exponent. And stays the same. I will reiterate, or maybe I'm saying it for the first time. I don't know. A negative exponent does not make a base negative. Okay? A negative power does not make a base negative. The base stays the same. Right? We have not run into a coefficient yet. How you would have a coefficient would be if you had something like 4x to the negative 6th. Anyone want to take a guess at how that would simplify? 4x to the negative 6. And keep in mind here now that coefficient is not affected by the power. Catherine? Very good. 4 over x to the 6th. Did we follow the rules? The negative power moved to the denominator and became positive. Our base of x followed it, but stayed the same. And the coefficient, which is not affected by the power, stays put. Is essentially what's going on here. Wherever the coefficient is, it stays there. What do you think? Pretty neat, huh? Oh, okay. But again, all discovered using patterns. This relationship had always existed, right? But looking at kind of what's happening, that's what mathematicians do. Okay? All right, questions on this? Yes.
I have a question on one that's at the bottom.
We'll get to that in just a second. Questions on this, because once I scroll down, the ink goes away. So I want to, yeah. You will. Yes. Positivity. Anything else? You also have like 15 minutes to work on it during class, so you'll probably finish it up. Okay. At the bottom, where we get to practice. Jack, what is your question?
I have a question on the top section.
Top one, second one? Okay. So Jack's asking about 12x to the negative ninth y. Okay. Really, the only thing that we care about in simplifying in this objective are the negative powers. That coefficient of 12, following the rule, that coefficient is going to stay put anyway, right? Because it's not affected by that negative 9. And that base of y, what's the exponent on the base of y, even though it's not written? It's a 1, right? If it was a 0, it'd have to be written there. It's a 1. That's a positive 1, right? So do we need to move that? No. The only thing that we're moving is that x to the negative 9th. And because it starts in our numerator, it's going to move to the denominator. The 9 will become positive. That base of x stays the same, but it follows it. And what's left in our numerator is simply 12y. There you go.
How do you do the next one?
Great question. The next one, we have 2 in our numerator, and then a 3 and the negative 5th in the denominator. What are we going to need to move? Alex? N to the negative 5th, right? And where are we going to move that to? The numerator. We don't touch that 2 because it's positive. We don't touch that 3, it's a coefficient. And so our simplified expression is going to be 2 n to the positive 5th over 3. Sophie?
I have technically 2 questions.
Yes.
On the second row, first one.
Okay.
So, when you move it up,
Yeah.
when you move the h up,
You would.
can you have to put a 1 next to it?
Okay. So Sophie's asking about when you move that h to the negative first up, which you have to do because it's a negative power, you could technically keep the 1 in the numerator, then put your h now to the positive first, and what's left in the denominator when you move that h to the negative first up? A 1. Or you could write it as just h. Yep. Because 1h the first over 1, all those 1s are unnecessary. Okay. What's that? You couldn't put a 1 because the h doesn't have any more h's to cancel out with. So you do need that h there, but all those 1s, a coefficient of 1, a power of 1, a denominator of 1, they're all hidden math, all identified on my neat poster in the back. But anyway, so there you go. What's your second question? Excellent. I'm that good. Anybody else? Questions on any from this first page? Beckman. Fourth one on the top. T to the negative third over C to the negative 10th. Can't get much more negative than this. My goodness. What are we going to need to do here? Claire. You're right. This negative 10 in the denominator goes up top. This negative 3 in the numerator goes down. You just switch them. Okay? Wherever you've got a negative power, just move it, make it positive. The base follows, so we have C to the positive 10th over T positive third. Anything else? We certainly have the time to go over some others on this page if you want to. Otherwise, I'm going to pause the video. Actually, why don't we do this? I'm going to pause the video, have you work through the others, and then we'll touch base before we officially assign homework. So, until soon. And we are back. Your job was to do these 4. The first one, 7n to the negative third. That coefficient of 7 stays in your numerator. The n to the negative third goes down, becomes n to the positive third, and that should be your answer. 7 over n to the positive third. The second one in the second row, we've got 2 things to move, this a to the negative 5th and the c to the negative first. The 18 being a coefficient stays put. that b, being a positive power, it's b to the first, even though it's not written there, that stays put as well. So 18b in our numerator, and a to the fifth, c, if you put c to the first, that's fine. If you just put c, that's fine too. Okay, when it's a positive one, we don't have to write it. Next one, two things to move again. B to the negative ninth, n to the negative seventh. So our numerator is a squared n to the seventh over b to the ninth, y to the 11th. Okay. And last one, just the n to the negative second to move. So 4y squared in our numerator, n squared in the denominator. Questions on this? Yes.
So what if it's like -2 squared? Would the negative sign be a coefficient?
Like that?
Yeah.
Yes. So that would not require any moving around because the power is positive.
I mean -2 squared. I mean like negative squared. Or like that.
Hold on. I think -2 to the negative second power. There we go. How would you handle this? -2 to the negative second power. This is a good question. Let's clarify this. Ellen. Keep the base negative. Change that kind of goes against our rule of the base gets moved but stays the same. If we make the base negative, that would kind of break that. Arlene? 1 over -2 times -2? No. This goes back to remembering order of operations, coefficients. Answer your own question, Claire.
Would it be like -1 over 2 squared?
Yeah. The base of this exponent is only the 2. That negative sign acts as a coefficient of -1. So we'd have a -1 in our numerator over 2 to the positive second power in our denominator. Okay. If it had parentheses around it, like that, now the negative sign's part of the base. So in this case, this would be 1 over -2 the positive second power. The negative sign would follow because it's part of the base, and we need these parentheses here to keep it part of the base. Okay? Great question. Good stuff. Anything else? All right. Looking at your homework due tomorrow, it's a review of everything we've done so far. The top row goes back to CO10. How do you know that this is CO10 multiplying by the same base? Because it's got the multiplication symbol in it. Okay, that's your hint. Okay. Second row, CO11 dividing by the same base. How do you know that you're dividing by the same base here? Because it's got the division symbol in it. It's a fraction. Okay. Third row. How do you know you're dealing with the zero power rule here? Because you see the zero exponent. You'll also notice that some of these you do need to simplify or use other rules, like this last one here, t to the 8th times t to the 6th. I don't see any zero powers there, but we have to simplify our numerator first to see what we get, and then we can go about simplifying. And then the bottom row, negative powers. Because you've got negative exponents, you know it's that rule you're using. And that's as far as we've gotten. Okay, Beckman. I'm going to let you work this one out yourself. I'm not going to answer any questions on this one. As far as that goes, Beckman, just take a look at whatever's got a negative power is moved. Okay? Whatever has a positive power stays put.
If the base is negative,
Shh, folks.
and it has a zero exponent, would it still be 1?
One like this, -9 to the 0 power, is on your sheet for CO12, on the sheet that we went through. I'm not going to answer that question, but I'll tell you where to look. Okay? She's asking, how does that negative sign affect it here with that 0 power? There's one like this on your homework sheet from CO12, so go back and take a look. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? No? All right. Why do you have homework? This is practice. Don't call it homework, call it practice. Opportunities for glory. Yeah. If you all do your homework, then tomorrow you get 10 opportunities for glory. So there you go. All right, folks, that's how you math.